Okay, we're looking at the first year core textbook, mixed exercise 5, which is on straight line graphs, from question 17. So quite a long one, but at least it's broken down, and we can see it's an exam question, so we can see how many marks each part's worth, which helps us know sort of how much work it should be. And it's also problem solving, so there's going to be a little bit to think about. Okay, so we should only need the first part of the question to be able to answer A, so if we cover the rest of it up so it doesn't distract us. Okay, so write an equation in terms of x for the distance between those. Okay, so this is just using the formula for distance, and just rather than have two coordinates, we've got one coordinate and then we've got just a general coordinate. So the formula is the difference between your two x coordinates squared and then the difference between your two y coordinates squared. The other slight issue I have is it says in terms of x. So if it's just in terms of x, I can't have y there, but that's fine. So my first coordinate is -1, 5. My second coordinate is x. Then it tells me that this is on the line y equals 3x. So rather than call that coordinate y, I can just say, well, generally, the y coordinate is going to be 3x, and then everything will be in terms of x. So the distance will be, so the difference between the x coordinates, it doesn't matter which way around I subtract, so I'm going to do x minus -1, just because then I don't have any minuses to worry about, and then 3x minus 5. Okay, and to be honest, I will simplify it, but that has answered the question. That is an equation in terms of x, but I suspect we need to simplify it later on anyway. Yeah, okay, so I'm kind of blurring from A to B now, but I'll need to have this simplified for B anyway. So let's square out those brackets. So x plus 1 times x plus 1 will be x squared plus 2x plus 1. 3x minus 5 times 3x minus 5, which should give me 9x squared minus 30x plus 25. So that's just, so for example, the 3x minus 5 all squared is 3x minus 5 times 3x minus 5. So if you need to just do that as separate working, that's absolutely fine. Okay, so let's tidy that up. So I've got x squared plus 9x squared. I've got 2x minus 30x. And I've got 1 plus 26. Sorry, 1 plus 25. Okay, so that like I said, I've probably already started earning some of my marks for B. So find the coordinates of 2 points B and C that are on this line, which are a distance of √74 from point A. Okay, so we don't need to restart this whole question. Basically, this is finding the distance of any point on the line 3y equals 3x from whatever the coordinate was, -1, 5. So I just need to find the 2 point, and the reason it's 2 points is because I'm going to be solving a quadratic, so that's fine. I'm expecting possibly 2 solutions. So when does that equal √74? So when does the distance equal √74? So let's get the whole thing written out. Okay, so the first thing I'm definitely going to do is square both sides, because that will cancel the square root. Then I am going to minus the 74. So obviously it's a quadratic, so I need it to equal 0. And I'm going to say that's 48. I'm not writing any equals there. Minus 48, yeah, I think I'm okay. Then I could just stick that into my calculator. I'm going to hazard a guess that it probably factorizes, so let's try this. I'm going to cancel through by 2. If it does factorize, obviously it's got to be 5x and x. 8 and 3, 6 and 4. Yeah, I think 6 and 4 is going to work, because I can do minus 20x plus 6x, yeah. But so whichever's quicker, you can get these solutions from your calculator. So that will give me minus 6 over 5, and that will give me 4. And I imagine I need the coordinates. Find the coordinates, yeah. And it doesn't sort of say which one's B and which one's C. So don't forget, so these coordinates are both on the line y equals 3x. So that's going to be the easiest way to get the y coordinate. So if I multiply minus 6 over 5 by 3, I get minus 18 over 5. And if I multiply 4 by 3, I get 12. And then do just give them as coordinates. So minus 6 over 5, minus 8 over 5, and 4, 12. Okay. So on to part C. What have I got? Find the equation of the line L1 that's perpendicular. Okay, so actually this has got a bit simpler, I think. So if it's perpendicular to y equals 3x, it's got a gradient of minus a third, and it's going through minus 1, 5. So I'm going to use y minus y1 is m times x minus x1. My gradient is minus a third. My x coordinate is minus 1, and my y coordinate is 5. So y minus 5 is my gradient times x minus minus 1. So that'll be x plus 1. What am I doing? Part C? Yeah, so they don't specify what form. I'm going to multiply it by 3 just because I think it's the easiest way to do it, but you can multiply those brackets out. So I'm going to multiply it by the 3, and then I'm going to multiply the brackets through by the minus 1, and then I'm going to make everything equal 0. I'm just going to double check. I think I'm okay on that. Yeah, so any version of that would be fine though. So for example, if you did y equals mx plus c, then you ended up with that. That's absolutely fine. They didn't specify what form to give it in. Okay, so find the coordinates of the point of intersection between line 1 and y equals 3x. So line 1 is this one that we've just found. So and the line y equals 3x. So I think what I would do for this one is just substitute 3x in for y. There's plenty of variations on how you might tackle it. They're perfectly fine. So 3, and then when it says y, I'm going to substitute in 3x plus x. I'm going to have to write a little bit wonky because I'm going over myself. So all that is me substituting y equals 3x into that equation there. So that would give me 9x plus x, and then I'm going to add the 14 over. So 10x is 14. So x is 14 over 10, which is 7 over 5. And again, so don't forget to find the y coordinate, but it's on the line y equals 3x. So that's the easiest way to find it, is just to do y is 3 times 7/5, and just make sure you do give it as a coordinate. Okay, then area of triangle ABC, it's only worth 2 marks. So I think the hardest bit about this is just going to be reading back through it and figuring out what's what. Okay, so what do we know about A and B? Well, we know that, so we've got the coordinate of A. We know, and we know B and C. Okay, well, so let's just start drawing it out. Okay. So A was at -1, 5. So let's put that about there. B and C were my answers to part B. So let's find those. So 4, 12 can go sort of up there somewhere. Doesn't matter which one's B and which one's C, so let's call that one B. And was it -6 over 5 and -18 over 5? So somewhere, so -6 over 5 would be good to go back there. Okay. So -6 over 5. Oops. A little bit so you can see the whole thing. Okay, so there's my triangle. So I'm saying that that's C. Well, the area of that triangle. So what else do I know? Well, I know that both of these, so looking back to what we did in part A, or part B, well, we got these new coordinates B and C from the fact that they're root 74, a distance of root 74 from -1, 5. So both, so it's an isosceles triangle. Okay, so that could be quite important. And I know that those two lengths are root 74. So what else do I know? I know where the line L1, okay, so line 1 was perpendicular to 3x, and it goes through -1, 5. So, and if you think about that, that means, if I think about a line that's perpendicular, so don't forget, so this is the line y equals 3x. Yeah, so the hard bit about this question, I think, is gathering all the bits of information you've used. So y equals 3x, oh, sorry, I didn't actually push my coordinate there. So the line y equals 3x is the line that goes through B and C, or B and C are both on the line y equals 3x. So we found a line that was perpendicular to y equals 3x and goes through A, and then putting that together with the fact that's an isosceles triangle, that's going to be half the triangle, and then obviously that's going to be the other half. So if I can find either of those areas, I can then just double it for the triangle I want. Okay, what else have we found out? So we found the points of intersection. So we found, running out of colours, we found the point of intersection between that perpendicular line and the line y equals 3x. That was our answer to part D. So let's find that. So that was 7 over 5, 21 over 5. So if I look at that pink triangle, I can get, yes, it does feel like a lot of work for 2 marks, but we'll go with it. So I can get the base of that pink triangle by doing the distance between 412 and that. So let's get that. So that's going to be the length of the base of that triangle. So that's going to be the square root of 4 minus, sorry, it's the right mess, let's try that again. Okay, so that's going to be the square root of 4 minus 7 over 5 squared plus 12 minus 21 over 5 squared. Let's get straight into my calculator. 4 minus 7 over 5 all squared plus 12 minus 21 over 5 all squared. So that's giving me, I'm not going to bother simplifying it, so square root of 338 all over 5, and that's all within the square root. The height, what colour am I used? Use blue. Okay, so the height is going to be that distance there. So again, same formula. So I'm writing underneath it, and we have space. So that's going to be -1 minus 7 over 5 all squared plus 5 minus 21 over 5 all squared. So again, that's going straight to the calculator. So -1 minus 7 over 5. Okay, so that is giving me the square root, so I'm not even bothered putting the surds into my calculator. So that is giving me the height. So, I mean, I'm just going to find the area of the pink triangle and double it. Obviously, I could just double that, and that would be the total base of the triangle. In fact, I'll take it back, I'm going to do that. It doesn't really make any difference, but that seems a slightly more sensible way to do it. So that yellow base is actually 2 times root 338 over 5. Okay. Really, probably should have been checking these answers as we go. So mind, okay. So half times base. Really careful. So that square root is over the whole fraction. So half times the base times the height. And okay, so 32 over 5 times 338 over 5, and obviously the half times the 2 is going to cancel. And I am getting that. Okay, so that does seem like quite a nice round figure. Keep our fingers crossed. So I'm getting that's my final area, and I don't have to double that because in the end I doubled this to get the base of the whole triangle. Okay, right, let's hope. Oh, thank goodness for that. Okay, so we've got that. Let's just check through our other answers. I'm just scrolling back through. Yeah, and as we said, so going back to part A, we did have full marks for part A at this point here. It didn't sort of mention having to simplify it or anything, but then we needed to. Oh no, hang on, sorry. Oh no, they have no. So sorry, for part A, they have given out the expanded quadratic. So yeah, so we did need to just simplify it down and collect the right terms together. Okay, right, it's quite a long question.